All right, I'm going to go ahead and get this started. Well, hello, everybody, and welcome. I'm AJ O'Neill. I'm going to go shut a door real quick that I forgot to shut, and then we will get started. Tonight, I'm doing, so at the UtahJS conference, I did this JS with Types talk, but I was given a very limited time slot. And so I don't feel that I was able to give it adequate justice, and I wanted to do the skin, and I wanted to have a little bit more audience participation because we didn't have quite enough time for that to get questions and answers and stuff like that. So give me just 1 second to close this door, and then I will be back. Okay. So my name is AJ O'Neill. Like we said, I think most of you that are joining in right now know that. My Twitter handle for my good tweets is @_beyondcode. And then you might actually be watching this presentation on YouTube, so you already know I'm CoolAJ6 on YouTube and some of the other platforms. I'm a dangerous wrong thinker, equal opportunity offender, and technophobic technologist extraordinaire, which is why I like JavaScript with types, but not TypeScript. Skip over some of this other stuff here. All right. So, I just heard somebody speaking in the background. I don't see other people, though. Where'd that come from? So, the idea of JavaScript with types is to be able to have types without transpilation, and also to be able to have types in JavaScript without replicating a C++ or C# style deep inheritance hierarchy. And the tools that we're going to use for this are going to be JSDoc and TSC, which is the TypeScript checker. So we don't need to use TypeScript the language, but we are going to use TypeScript the tool. And the config is kind of difficult to get set up, and so I created a command, JSWhat, stands for JavaScript with types, that will configure the TypeScript checker file correctly so that you can actually take advantage of this without having to do a lot of research and have a lot of headaches. And with all that said, if at any point during this presentation you decide, hey, this is really valuable content, I like this, consider like, sub, follow, if you want to. And then here are some useful links. This is not where the presentation is hosted right now. This is normally where I host my presentations. This presentation is actually hosted at jswithtypes.com. I think I will also alternately host it on the beyondcodebootcamp.github.io. This is the previous video. We'll update this with this video. And then people always ask, what do you use to build the slides? So it's called MD Slides, and you can check it out right there if you want to. And then here's useful reference material that some of which we're going to be covering during this presentation, just so you have it handy right there up front. All right, so as I kind of alluded to, this is not a gateway drug to TypeScript. I don't like TypeScript. If you're here, I expect that you probably don't like TypeScript either, and that's just great. Instead, we're going to be coding like it's 1999, very classical JavaScript in a sense, but not classical as in inheritance oriented, but as in, old. And this is kind of something that I hope people who are into Go and into Zig and kind of are forced to use JavaScript, I hope that this is more the gateway drug to them into JavaScript so that you can have a good time and not hate life. So I've already kind of talked about this a little bit, but I want to nail down the philosophy. Why are we doing JavaScript with types rather than TypeScript or another language? Well, as to why not another language is because, you have to use JavaScript sometimes. You just can't avoid it. But build steps are just not good. I think that generally we know that build steps complicate things. They slow things down. They create a higher transfer of knowledge. And slow build steps are particularly evil. You don't want to have to be waiting long cycles in between testing something, and you don't want complicated build steps where what you are testing and the error messages you get and the kind of code you have to crawl through is different than the code you generated. code gen is better than metaprogramming. When you have really, really advanced type systems that allow you to describe every possible way that you could ever do any sort of typing, you tend to get sucked into this loop of using them. Just because you can doesn't mean you should, but when you have this whole plethora of things to learn and it's really exciting, you can start to want to figure out how to write less code and use more typing. And I come from the philosophy that it is better to generate more code or copy and paste more code than it is to have lots of metaprogramming and lots of intra-language features that you then have to somehow knowledge transfer and pass on to other people. Also, I think that duck typing is just good in general. I think that Go has shown that duck typing works really, really well. Just the idea of simple types and interfaces. You can do everything that you can do with complex types and interfaces, but again, lower knowledge transfer. And I think inheritance is generally evil, and I think most of the programming gods agree with that. So we want composition over inheritance where we can, duck typing over inheritance. Inheritance is in a lot of cases, I don't know where you really need it, but if you do need it for some reason, hopefully it's a last resort. So we can do all of this with JavaScript. JavaScript avails itself to duck typing. JavaScript did not have any way of doing inheritance, prescribed way of doing inheritance. People use the prototyping system to do that somewhat, but that was really more to extend the language to fix bugs, not to recreate a C# or C++ programming vibe. So if we have better tools, then we can be better developers. Tooling is really important. And, well, I'll get to this in just a second, but one of the problems that we've had with JavaScript is the tooling. There's never been a strong focus in tooling in JavaScript. It's always, well, let's go build another language. Let's build a transpiler. Let's build something to interpret an advanced preview of some new specification that might become JavaScript at some point in the future. But JavaScript tooling has just been generally really bad and not an area of focus. Then I kind of already talked about this. Copy and paste and find and replace are not bad. Transpilation is evil. That could have gone up with the front there. And all of this it's just recycled. I'm not coming up with new reasons why we'd want to program this way. You can look at the Unix philosophy, the Zen of Python, the Go Proverbs, the Zen of Zig, the Prettier Rationale, AHA Programming, Agile Manifesto. All of these are linked to from creedsofcraftsmanship.com. All of these things kind of point us towards, let's use smaller languages, smaller feature sets, be more focused, and try to root out complexity and mental burden. And sorry, I didn't see your message there, Kano. Duck typing, we'll get into that a little bit more as we look at some examples. But duck typing, the idea is if it quacks like a duck, it's a duck. If it walks like a duck and it quacks like a duck, then it's a duck. So if you have an object that matches a certain pattern, then, which we often call an interface, by virtue of the object matching the interface, the object inherits whatever that interface has to offer without any special designation. That's duck typing, and that's how JavaScript works by default. Okay, so now we're on from the philosophy. Types, this is something I think everybody needs to understand about types. Types are and always have been in the tooling of the language, not in the language. So when you look at C, when you look at Go, let me move on. When you look at these typed languages, the types are actually in the tooling, because if you deliver the binary to be executed and the tooling has not checked what the type is, then it's just going to run whatever unsafe code. Now, with languages like Go, there is actually some dynamic runtime that will do some of that checking when the program runs, and so you could have corrupt data if you could somehow skip the tooling process in a language like Go. You could have correct data, and the runtime is going to catch some of those errors. Same with Java. But in general, the types are in the tooling. They're not actually in the binary that gets run. And so JavaScript has always had types as a language, duck typing, but the language hasn't or we haven't had tooling to offer them in a really good way. And when you think about static types, like I was saying, they're kind of a lie, because so you've got languages like C that they don't care about anything. If you can get past the tooling, whatever runs, it can break, it can crash, the types can mismatch, you can cast pointers to the wrong type, et cetera, et cetera. And then safe languages like Go and Java have always been dynamically typed because they've got a little bit of runtime that, the tooling takes on some of that burden so that the binary is more efficient, but when the binary actually runs, when it's checking to see, does this thing match an interface, there's some dynamic code that it has to look and see, okay, I got this object, is it one that matches this interface or that interface? And then it has to switch, and Rust does this as well. Yeah, compile time checking is definitely better than runtime checking. Yes, we want that, and that's the thing that I'm saying that JavaScript has largely lacked. Okay. Now, as far as just understanding the vocabulary, especially for people that are coming from the JavaScript background, there are some things that you need to know about types of types. And if you come from other backgrounds, you've probably heard almost all of this, but we'll go over it a little bit anyway. I don't use the word kind of static polymorphism versus dynamic polymorphism. I don't really use the word polymorphism very often. I kind of lose track of what it actually means in code. But yeah, we want to look ahead of things as much as we can and determine the shape of this versus the shape of that. Polymorphism means multiple shapes, but what that means in any given language is a little bit different. Okay, so in our types of types, we have our primitive values. This is stuff that you mostly know. So in JavaScript, we have Booleans, we have number, which encompasses both int and float. It's a 51-bit integer, I think, is as high as we can go. You can get 32-bit integers for bit shifting. They're 31 by default, and then you can have 64-bit floats. And that's all kind of masked under the hood, but that's the way number works. Then you have strings. They're collections of characters, and also you can have collections of bytes as strings in JavaScript. And then you've got some of the newer types, big int, int and uint. And I say int and uint star because there's 8, there's 16, there's 32, there's 64. So all of your flavors in int and uint actually are in JavaScript. You do have those types, but you must use them in an array is kind of the weird thing about it. So because of the evolution of JavaScript, it has both loose and strict types, but they don't always work in the way that you expect. This is the nature of the beast. You also have functions, and then the idea of nullishness kind of applies across the board, whether we're talking about single value, multi-value collection, and some of the meta typing as well. But nullishness in JavaScript means null, undefined, or not defined, which are 3 distinctly separate states of nothingness. And we may go into that a little bit later, depending on the time. Under multi-value, we've got the struct, which is in contrast to the collection type map. So a struct is, I'll go into this a little bit in some future slides, so maybe I'll save that for just a minute. But we have the ability in JavaScript to do structs and tuples, and this is not tuple as in the new spec that may come down the pipe in a couple of years. We already have tuples in JavaScript. They're already there. We already have structs. Structs are just objects. Tuples are just lists, but not lists. But It's a tuple is describing a particular way you use a list. And then we've got weak map and weak set and a couple of other things which I don't. In certain niche cases you may find them useful, but I'd say typically avoid them. And then you have your collection types, map, which are your key value pairs, which in JavaScript is overloaded with object, and then list, which is indexed values, so values that have an order. Yeah, not defined, Kano says never heard of not defined. Not defined is a type of undefined. So when you check the type of not defined, the type of it comes back as undefined. Then we may get into that a little bit later. And then this meta stuff, we'll have a whole section on this. I'm not going to go over these in detail right now, but we've got new types, type aliases. Those are similar but different. Value enums, type enums, mix-ins, which you could also call unions or polymorphism, then templates or generics, and utility types. So let's just go on. Like I was saying before, because we have had bad tooling in JavaScript, JavaScript gets a reputation for bad types. This doesn't have to be the case. That's what we're here to fix. So take a look at this. You understand this implicitly, hopefully. We've got message is a string, answer is a number. These are things that we understand because we see it, but with the default linter or whatever, you don't get any checking on this. So what you can do is you can introduce JSDoc, which is a standard that's based off of JavaDoc. So it's kind of, we're using two weird technologies here. We got JSDoc comes from JavaDoc and follows all of its idioms, and then TypeScript comes from C# and follows all of its idioms. But somehow we got this little kernel of goodness that we're going to have in the middle here. So JSDoc allows us to use this annotation with a double star at type, and then the name of a type, which all of the JavaScript primitive types are just there by default. And this allows you to say, not only is this a string, but I expect it to be a string. It is my intention that message is a string. And so on with number. Now, JSDoc actually allows you to generate documentation, so you get a web page that shows, here are my types. And that's really cool. And more than cool, it's useful and helps to communicate intent. So that's what JSDoc is primarily intended for. It's to communicate intent to other developers of what you wanted to do. But it turns out that through the magic of the TypeScript checker, which I'll introduce in just a second, we can use JSDoc to inform the TypeScript checker what our intent is and communicate with it. So when you want to install JSDoc, this is pretty simple. It's just called JSDoc. And as part of the config that I'll show you later, there is a way to automatically generate docs in a docs folder that have your type information. So TSC, what TSC allows us to do is to get errors. So let's say that I did @type string here, and then message equals 42. This is what TSC gives us in VS Code or in Vim, and you get this just by virtue of having TSC installed. So you don't have to do anything special well, you do have to have a config file for TSC, but you don't have to do anything in your editor that's special. Your Ale with Vim or just VS Code by default is going to understand TSC and going to be able to give you the little squigglies and give you your error and say, hey, type number is not assignable to type string. So, oh, oops, I transposed these. I accidentally assigned 42 to message, and I accidentally assigned my message to answer. And so I can get my errors and I can see what's going on here. So the purpose of TSC, in contrast to JSDoc is communicating intent. TSC is helping to catch, correct, and classify errors at dev time. We don't really have compile time in JavaScript, but it's helping us catch those, catch, correct, and classify at dev time, which is what we want to do. We're going to push it further up the way. Now, in order to install TSC, like I said, you have to install TypeScript. TSC comes as part of the TypeScript package, but don't be scared. We're not going to deal with TypeScript. It's just a tool that comes with it. And so pretty simple, npm install, yada, yada. And like I said, it's the TypeScript checker. So when you combine JSDoc and a TSC together, you can have more robust tooling in JavaScript. But the config is a little bit difficult to figure out. So this is kind of an abbreviation to figure out which of these options to select on your own by looking at blogs and stuff. It's kind of a headache, kind of confusing, kind of too hard. And I think this is one of the biggest barriers as to why not go into JS with types, is who can figure out those options there in order to have this stuff actually work. And that's why I created a tool, JSWhat, and this is available as a package that you can use just straight via npx, or you can install it. So you npm init your project, and then you run your npx JSWhat init, npx JSWhat reexport, And we'll talk about re-export a little later on. And this will give you that JS config.json with all of the correct options set so that the TypeScript checker will properly work on JavaScript, because by default, of course, it's meant to work for TypeScript, and it won't run by default on JavaScript project. So JS what? Again, JavaScript with types. You can remember it pretty easy. JS what? JavaScript with types, JS what? Okay. And so what this is going to give you is your jsconfig.json, your JSDoc.conf.json. It is also going to template out a couple of the files that you would use. So whatever your project name is, it's going to create your lib projectname.js along with an index.js. And this ends up being important in that all of your types actually need to end up being re-exported, talked about that earlier, from your index.js, so that when someone else uses your project that you've published to NPM or to Git, when they go to use that, you want those types to be discoverable, so that whether they're using TypeScript or they're using JS with types, that they don't, they get the linting that TSC has to offer. And so you wouldn't use index.js for your actual code. You'd nest that down, and I might show an example later of how this is done, but this tool will create the file for you with the right steps and the right stuff. You're going to have your docs folder. You're going to have your prettier ignore, because you don't want that to run on your docs folder and on your package lock or package JSON. Your package JSON here will also be updated with a couple of commands when you run the JS what that will allow basically the lint and the format command. And let's see, types JS and typings. Typings is a folder that allows you basically to add more information to something else. So for example, with Express, I often overwrite the Express default request object with some simpler. So for example, the rec.query in Express can be a myriad of things. It can be keys mapping to arrays or strings, or it's got a couple of other options. And so there's things that I do that I basically overwrite the types of other things to make them simpler, or to add things that don't exist. Often in Express, for example, you want to have a rec.user. Well, that's not part of Express, but in your typings folder, you can add that in. Okay, so what you're going to get is, like I said, you're going to have a fumped command, a lint command, and a re-export command that will come with that. And again, that's JS what, and this website, JS with types, will probably morph into documentation and examples that are coming from this slide. So those links. Yeah, so we were talking about, earlier I was mentioning JavaDoc and C# had a baby, and that gave us JS with types. So this is what our syntax ends up looking like because of that merger. Our type syntax is double star. It's a block comment, a normal JavaScript block comment almost, but instead of a single star, it's a double star, because this is allowed by the the block comment syntax, and this lets both JSDoc and TSC know when I encounter this, I'm going to look at this and try to interpret it as type information, either in general or particularly for the very next line that comes after it. And then if you want to do inline type comments, which you will often want to do for one-off, just put an @ type on top of something. You've seen before, it still has to be a block comment. You cannot do an inline type comment, but you can make it inline by just closing it off at the end. So we've got that there. So inline type, you've already seen this. It looks like this. We just throw the double star block comment, @ type, and then give it a type name. And if you want to do inline parameters on a function, so the inline typing is if you have a variable and you want to say, hey, I am not initializing this right now, because if we were just initializing it to a string, it can do inferred typing just like Go can. But if you're not initializing it right there, but you want to say, hey, this must be of this type by the time it gets used, that's where you throw the type on top there. And then for inline parameters, you do @param. So for example, we have here a greeting, which is optional. If you don't provide a greeting, then it just becomes the string hello. And then a options object, or not an options object, an other object. So this is going to greet another person, and a person has a name property here. So this is defining, okay, the square brackets say this greeting is optional. And then you'll notice I have 3 params right here, but there's only 2 things that are being passed into this function. That's because when you inline parameters and you want to describe an object, you just define the object as a param, and then you continue with @param, and then you can define the properties of that object, and you can nest it infinitely deep. Although if you start nesting it more than one level, you probably want to pull that out into a type definition that we'll talk about in just a second. So here we go. So struct definition, also known as a type def. So if you want to define a struct, then the way to do this is to have a comment for the entire struct goes first, and then you have @typedef in the name of your struct, and then you can assign properties to your struct. So this @prop, the type is number, and the number goes in curly brackets. You've probably gathered that by now. And then the name of the property of that struct, and then the comment for that property. So comment for the entire struct goes up top, or the short or long description. The short description of each property goes to the side after a hyphen. And then if you have something like an array or a promise or something that is a container, not a type unto itself, then you use the common convention of the angle brackets to say this array is of type person. So there's our friends, our mutual follows. And then you can have functions as well. And we'll show the way to define a function momentarily, but in this case, the type of this function is called fooGreeter, and then it's the name of the function is greet. So that's that. And then of course we can use this type def on a variable. We say @type person, so whatever we type def it. And we'll talk about this a bit in a minute, but this types apply to a file. The way that the TypeScript checker works is that types are considered to be basically variables in browser JavaScript. That's how it was designed. It wasn't designed with Node in mind, it was designed with the browser in mind, and so the types are considered to follow the same rules as var, except that they are scoped to if there is an exports or a require or an import, then they are scoped to the file. If those things are missing, then it will actually scope it globally, meaning not just to your project, but if there's a global type anywhere in any package that you use, it becomes global to everything as part of the global types, and then can be overridden by local types. So basically the same way var works. Okay. So if we want to do a function definition, thing you got to know is that it's actually @callback. For historic reasons, and JavaDoc didn't originally have a way to define functions. That wasn't what JavaDoc did. And the person who created JSDoc was emulating JavaDoc. They wrote their JavaScript like Java, more than they wrote it like JavaScript to some degree. And so we're stuck with the name @callback, but @callback doesn't mean callback at all. It has nothing to do with callbacks. It means function. So that's just a little gotcha. But it's pretty much, function definition is pretty much the same as a struct definition, except that we're going to have param instead of prop. So @param instead of @prop. And then you also have your @returns and @throws. And @throws can specify a specific error type if you have one that you want to do. So like I was saying before, very commonly, most of your functions are going to be async, or maybe not most, but a large number of them. And so your @returns, you're probably going to do promise and then give it some type of the thing that returns. So here's our greeter function, and it's going to take a name. Actually, this was supposed to be message. This is supposed to be greeting. That's a typo. So this was supposed to be, it's going to take in a greeting, and it's going to take in an other that has a name, and then it's going to return the constructed string of the greeter. And so just to kind of give an idea of what that looks like in code, here we are. Nothing too special there, but just demonstrating that we're documenting returns and throws, etc. All right. So I already mentioned this, but there it is. there is a document in JSDoc. You will find that there is an at function, but for historical reasons, that doesn't work. The TypeScript checker only works with at callback. There's actually 3 different ways in JSDoc to define a function, but at callback is the only one that works. At function does not work. And the other one works sometimes with some things, which makes it a bad choice. So at callback is the way to go. And if you're interested in that bug, there's the link to go bug Microsoft about it. So at prop versus at param, I just wanted to make this clear. So in JavaScript, a function is also an object. A function inherits from object. And so a function can have properties. So you can document a function that has both parameters and properties. Actually, I don't know if that's true. It won't give you a syntax error. I have not personally tried this myself because the use case for this is very, very unusual. But JSDoc allows it, and I'm not sure whether TSC supports it or not. But yeah, you could have a function that accepts another, and that function also could have a property foo that's bar. Okay. And then we've got our nullish definitions. So when you define a type, if you want to define it as being nullish, the question mark is a literal null, meaning that the property must be defined, but it can be defined as null. If you want to allow a property to be either null or undefined or not defined, then you would need to or that. And so this is our first instance of seeing a type enum. So this is actually a type enum. We'll talk a little bit more about this later, but you can take types and you can or them together to say it's this type, or it's this type, or it's this type, or it's this type. So you can say this is a nullable Boolean, or it's undefined. Now technically you could do Boolean or null or undefined. I believe there is a syntax that allows you to define that something is null or undefined, but I don't think TSC follows that syntax was the problem, and so you have to end up doing undefined. Now, you don't typically have to do this a whole lot because when you're talking about parameters that are optional, there's the square bracket. So if it's a type you're defining, you have to do or undefined, but if it's something you're receiving as a parameter, you can use the square brackets around the name of the property. And we'll see another example of that. I'll point it out again. Okay, then we have our map types. So you can have different types of maps in JavaScript. Maps are represented with the object syntax. So it's object dot, and then the key type, and then the value type. This is how you define, this would be a string map in JavaScript. And we could also have a string number map. So you can actually narrow, we'll talk a little bit later about value enums and type aliases, but essentially you can only have a string for the object key value, or sorry, the type of the key. Of a map must always be a string. That's all that JavaScript allows. The value can be a number or a string or an array or another map or a struct or whatever, or a function. But you can give an alias. You could, for documentation purposes, you can say this is specifically supposed to be a name. And so for documentation purposes, you could have alias string to name, and then you could put name here. So what you cannot do number, you cannot do function, you cannot have any other type to a map for its key. And then you can also, there is an any type, which is something that maybe should have been on the first slide. I guess this is kind of a meta type, the type of type slide. But I recommend not doing this because generally speaking, you have to really think about why you would want an any type. Because generally speaking, with very, very few exceptions, you don't ever want just a bag of stuff that is ID in something. There are a couple of cases for caches that take different types of objects, but generally they're similar types. So even if your type that you're defining is just must have an ID property, that's a type. Any is the non-type type. It is the whatever goes type. but you can put that there. I just think generally you're losing the value that you're creating. And then tuple types. So tuple types are defined with the square bracket syntax, and this is to distinguish from an array, because a tuple, when we look at literal JavaScript, the way that we define or destructure a tuple looks like the way we define or destructure an array. But in fact, a tuple is a different use case of an array in the same way or rather a different use case of a list. And so tuple versus list, map versus struct. But you can see here, you can define what the types are. Tuples are generally a list, but it's a list of a defined number of elements. It's only 2 or 3 or 4 elements in the list, and then you define the type of each element in the list. So it's not an array of numbers. It's a tuple where the first element is a result and the second element is an error, for example. And so the people that are from Go, they'll get this. People from Rust will get this. A lot of the languages that use tuples and things that are like tuples, you know, that looks pretty familiar to you. And in JavaScript, the syntax for destructuring a tuple would be just to use the square brackets like I'm showing there. So there's only really one use case that I've ever come across where two. I tried to emulate Go's error handling system with tuples, but I just think it's too not familiar to the way that people code JavaScript to really use. And then the way that Socket.io results work is they have an event name and then an event data, which is an any. So that's one case for using an any. And so that's this is I don't really use tuples in JavaScript, but I think it's important to know that they're there. They are a common type of type. All right, now for type extensions, so if you have a base type and you have an extension of that base type and you want to produce a new type, this is how you do a type extension. So you do the AND operator. You say type def, and I'm going to have my base person that maybe has name and ID are the only properties of the base person, and then you can AND that with a person extra, and the person extra might have the friends array and the social security number or whatever. So you can AND these two together. This is essentially a union or a mix-in, and then you can generate a new type that's person. And this is a specific syntax for type def where you provide the extension happens between the curly braces. So any extension that you're doing has to happen in here. And I'll show an example of why that is in just a minute. You can also have, this would be a type enum, where we might have a file type and a folder type and a symlink type and a pipe type, but all of these types are representative of a directory entry. So this is a kind of the canonical example of a type enum would be that right there. And then we also have narrowing functions. So if we have a dir entry, we want to be able to go back from the dir entry to something specific. So if this is a file, I want to execute some code that accepts a file, and I don't want to get an error that says type, file or folder or symlink or pipe is not assignable to file. That's the error that I would get if I didn't have a way to narrow the type down to some original type. And that's what this does for me. So I can have a function, in this case I call it isFile, and the money shot is right here. We say that dir entry is file. So if TSC encounters a place where I have a returns with a parameter name is type name, then after that function has been called and evaluated true or false, it knows that it can narrow the type. So if isFile returns true on some object, instead of getting an error that says cannot assign file or folder or symlink or pipe to type file or to type folder, it would just allow it to pass to type file and would still not allow it to pass to something that needed a type of folder. So that's how you do your type narrow. And then we have our utility types, the most useful of which is partial. And partial essentially allows you to find something that is like the type that you're interested in. So maybe person has lots and lots and lots of properties, and you have a few functions that may operate on some of those properties. You can type def person like as a partial person, and what this means is every property of the person now becomes optional. And so in that function, you could do checks. You could say if person dot social security number, then do this. If person dot whatever, then do that. And so you can have a function that can handle multiple aspects of different super and subtypes of your person. So, you know, your base person, your person extra, etc. And then these are called utility types in the TypeScriptLang.org manual. I'm not really going to go over too many the other ones because I don't find them to be super useful. But there's an omit, there's a required, which does the opposite of partial, some stuff like that. Oh yeah, here we go. So if we wanted a full person where all of the properties have to be defined, you could do required. But here's the thing that you need to know, because intuitively you might think, okay, well, I want to be able to extend this type, but I just want to extend it in line. So I'll type def this, and I'll give it my base type, and then rather than doing an ampersand, I'll just add new properties. So I'll just inline extend this type to be the new type I want it to be. Unfortunately, this doesn't work. There's probably a bug open for this on the TypeScript checker. I think that this works in JSDoc. I'm not 100% sure on that, but it does not work with TSC. There's just lots of quirks all around this. That's kind of one of the problems why not JS types? Why use TypeScript instead? Why not just use a narrow subset of TypeScript? Well, one, that never happens. Once you unfold a set of tools to people, they're going to use every tool in the toolbox. It's very difficult to come up with coding standards for something like TypeScript because there's just too many options. But why not JS with types? Well, because there's all these quirks that I'm telling you about. If you use TypeScript directly, you've got access to a whole boatload of types, but then you've got the transpilation, and then you've got that mental overhead of too many types. So this is why I created this presentation, is so these little things like this, these little gotchas that you'd be scratching your head on and looking up in documentation, I'm just trying to get out in front of you. Okay, so in addition to utility types, we have utility functions, and this is one of the rare cases where you might actually want to use any. So utility function is basically stuff like Lodash. It's where the function itself doesn't know anything about the type of data, it just knows metatype information. So a utility function knows that it's an array, or knows that it's a function, or knows that it's, by array I mean list, or knows that it's a map, or knows that it's struct would not be useful to a utility type because struct has to have some sort of information about it. But anyway, so here's a utility type last, and I'm going to pass in a list, and it's going to give me the last element of the list. So this is kind of annoying to write out the array sub r.length -1. It'd be nice just to have a function that if I pass in a list, it gives me the last element of the list. This is an appropriate utility function. So I would say this accepts an array of type any, that's my list, and then it returns any. Well, this is actually a problem. This won't work. That's why I put the little e. This won't work as expected. What we actually have to do, if we're doing a utility function, we have to use a template type or a generic type. So what we do is, in this case, we don't do any narrowing, but I just put it here for consistency. It's easier to learn one syntax than multiple syntaxes. So we can say our template is of any type T, and then we take an array of type T, which is our list, and this returns type T. And the good thing about this is, in this previous example, if we did this, if we passed in an array of people, what we would return back would be an any. It would lose its type information as far as TSC is concerned. When we do this style, when we pass in an array of persons, then what it returns will be of type person. And the function itself doesn't need to know anything about persons. It just returns whatever type you gave it. And then we have some utility-ish functions. And the reason I say utility-ish is because a true utility function has no type information. It's just going to look at the thing and say, I don't care what type this is because I'm just doing a utility function. I'm just returning last. Utility-ish functions would be functions that are scoped to some likeness of a type, such as our person-like type, and can do some amount of stuff with it, but it's scoped to that particular use case. So in this case, we could have a utility-ish function that's person.sanitize and could take in anything that is person-like, and then if that person-like type happens to have SSN, it's going to mask out the social security number and then return the person. So I think this is a pretty ideal example use case for this. Okay, so that's pretty much all of the features that I've used from JSDoc and TSC. There might be a couple more we'll get into. Now, if you want to use types that have been exported either by TypeScript or JS with types in other packages, then if it's JS with types, then just installing it with npm should be enough because the type information will be in the JavaScript. If it's a TypeScript package that is pseudo TypeScript, meaning that Node isn't TypeScript, but somebody published a definition for Node. Express isn't TypeScript, but somebody published a definition for Express. That's where you do the @types organization on npm is owned by Microsoft TypeScript, if I'm not mistaken. I believe that is official. I hope so. And then you basically have the same package name as whatever the thing you're using is, and this will install the type definitions for TSC, so that things that are in the dependencies that you have, you can still have access to the type information for them. And so here's a really practical example. I'm going to create an Express handler, and I'm going to do import express.handler, and I'm going to use this to type this function. Or likewise, if I want to type the error request handler, and do the same thing. So you can do these imports. So that's how you import a type between packages. And if you want to re-export types, which JSWhat comes with a utility that will do this for you and re-export everything up to your index.js. But if you wanted to, say you've got 10 different places where you're going to use an Express handler, you don't want to, in every single one of those places, have to type out import Express handler, import Express handler, import Express handler. So at the top of the file, you can just @typedef import Express handler, call it handler, and then you can shorthand all of those. Now you have re-exported the type from the Express package to your current file. And you can do the same thing between files. So types that you create in one file are only available in that file. So if you need it in another file and you need to use it often, then you can just give it the path to the file, whatever the object or the type is, and then you can use it that way. Now, one interesting thing I've seen to notice, I think this is right, if you've imported one type from one of your own files, it seems like it then recognizes all of the other types that are in that file. I could be wrong on that, but that seems to be what happens. All right, so with that, we are done talking about the types of types and the types that can be represented with TSC and JSDoc. This is it. So give yourself a big round of applause, because now you know everything that you need to know in order to express any type of type that you can create with JavaScript. So you notice I didn't cover classes, I didn't cover inheritance. You can just take a type and it with another type, or it with another type. You can have a type, you can have a function that's typed and its return value is a struct that has certain properties and methods, and that's essentially a constructor. So everything this is everything that I use in my JS with types setup. So again, some important references for JSDoc, TypeScript, and yeah, just those two, I guess. And then now I'm going to take a brief pause before we deep dive, and we're going to go through a bunch of examples to see how we can use meta types and try to give pretty practical ones. But I want to take a pause. Are there any questions Feel free to unmute if you're joining in on the Discord. What can I answer for you at this point? Okay. Seeing no questions, I will carry on. So we will dive. So I talked about primitives before. I just wanted to give you an example of what some of the more strictly typed primitives looks like. Hey, Rego, how's it going? If you joined in to ask a question, feel free to ask that question. Or if you're just saying hey to say hey, that's cool too. So a big int in JavaScript is just a number that ends with an n, and typically you will use, a lot of people don't know this, but numbers in JavaScript have underscores as part of their syntax. So you can write an arbitrarily long number, put underscores in it so it's easier to read, and then put in after, and that designates that it is a big int. Uint8 array, so you can have uints and ints, N8, N16, 32, 64, like I said. The funny thing is, you have to have a uint8 array to use them. So there is no way to define a single value that is an int8 or an int64. But there is a way to use them. They just have to be within a uint8 array or a uint16 array, int16 array, etc. And then there are some primitives that are really similar because of the way that JavaScript has evolved, such as buffer and array buffer. In fact, buffer is an array buffer, or maybe it's buffer is uint8 array. I may have actually gotten this wrong here, or maybe it's both. I can't remember off the top of my head, but basically there's a couple of types that are almost identical in this category. And so, and we also have another one that is similar, but maybe doesn't belong here. Is there's also binary strings, which are just strings. So we do have byte strings, array buffers, typed integer arrays, and big ints in JavaScript. So all of your normal scientific and mathematical types are available to you. They can be used natively, actually pure part of the language, not part of the tooling of JSDoc or TSC. And then there's some things that would seem to be primitive types, but aren't. And so, for example, date is a run-of-the-mill object in JavaScript, but this is actually an object. It's not a primitive type. And then regex, the regular expression, it has its own syntax, just like an array or a struct or an object or a number or string. It's got its own syntax, but this also is actually an object. So this is actually a constructor for a regular expression. It's syntax sugar for a constructor. So this is not a primitive type. Just kind of wanted to point that out. And we talked about this already, but I want to go over it real quick. Syntax versus semantics. So object notation in JavaScript is curly braces and a quote unquote array. There are no arrays in JavaScript, but the so-called array notation is square brackets. But the thing about these, the syntax is the curly braces or the square brackets. The semantics is the meaning, but the syntax doesn't carry any meaning because just looking at a JavaScript file, you can't tell from the curly braces whether it's a struct or if it's a map. It's one of those two things, or heaven forbid a hybrid, but when you see curly braces, it's either a struct or a map, but you don't know which from the curly braces. Likewise, when you see the square brackets, it's either a list or it's a tuple, but you don't know from the square brackets which it is because these two things, for both of these four things, do not have distinct syntaxes of their own. So types are semantic. They carry meaning. And we've already talked about this enough, so I'm not going to hammer it too hard, but you can think of a struct like it's a Mr. Potato Head. It's a kit of stuff that goes together. So a struct is plain old JavaScript. You know, we already go over this. Name, age, etc. A map is what in the world? Oh, I needed to fix this from the last time. some copy pasta went wrong here. A map is a collection of like-ish things. I think I was going to say phone book here, but I don't know. I don't know what happened. So you could, a map is, it's going to, the meaning of map is that it's a set of keys that are the same type and then a set of values that are of similar types. And in this particular instance, this example here I'm kind of showing is actually tuple-esque, because it's obviously multiple people are going to have the name Bob or Jane or whatever. So you have a very limited set of possible names for this group of people. Okay, yeah. So let's say that you had a map, a kind of tuple-ish map of people with great names. That's what your map is. So the allowed names are Bob, Jane, Avery, and Joy. And so your map is of type great name, comma, person. Then if you were to, so this is a value enum here, if you were to try to assign something into this map of people with the name Jack, then you would get error, Jack not found in Bob, Jane, Avery, Joy. And then you'd also get the error, object cannot be assigned to type person. And then tuples versus lists. We've already actually, this originally was here when this slide was before we talked about tuples so much already. But you think of tuples like an unopened Lego set. It's like a kit by numbers. So if you get a Lego set, there's bag 1, bag 2, bag 3, bag 4. And the bags have every type of Lego in them. But they're for a certain stage of the development. And so that would be, a set of Legos is a tuple. It's a collection of stuff that's unrelated, that some of the things are similar, some of the things are dissimilar, but they're indexed. And then we already kind of gave this example. One benefit to a tuple is that you're not constrained by the name because you're constrained by the index. So with a tuple, I could call this P, or I could call this person, I could call this error, or I could call it E, or I could call it error. And all that matters is the position. It doesn't matter what the name is when I destructure them. When you compare that to a struct, so here I could make this P and error. The struct, I could change the order of these. I could put error over here and person over here, but I couldn't change the name of them. So just kind of a quick intro there. Lists are ordered collections of like-ish things. Think Pokemon cards. They're numbered 1 through a billion. But when you don't actually have, there's a lot of things you don't have to type, and primitive lists are actually one of them, because it can infer, okay, this is obviously a list, and okay, this is of the same type, this is of the same type, this is of the same type. There's nothing that contradicts the type of this list, therefore this list must be of type string. So you can type it for the purpose of communication and documentation, but in terms of the TypeScript checker, it will know that a list is of a certain type if it's primitives. However, the same is not true if it's non-primitives. Because of duck typing, there's no way that it could know that something that has name and calories is necessarily a fruit. There could be other things that have name and calories, like cupcakes, etc. Okay, on to enums. So value enums, type enums, and implied enums. I kind of talked about all these already, although I haven't called out implied enums by name. But we have our value, or what I call weak sauce enums. These are kind of what you see in languages like C, and unfortunately, Go kind of makes reference to this type of enum. But it's not really an enum. This is just something that's numbered by an integer count that goes up by 1 for everything that you define. So there are uses for this, but like I said, it's kind of a weak sauce enum, but this is not generally what we're talking about when we talk about enums. There is an Enum JSDoc tag, and that does refer to this sort of thing. I haven't actually used that because it's very rare that I find this integer value style of enum to be useful. But if you're interested in that, you can look into the tag here. I prefer the more expressive type, because you can use this expressive type the same way you could use the integer type, and we don't have to be constrained to worried about the size of integers and stuff for how we're defining our enums in JavaScript. But yeah, you've already seen this before. We can type def something. We can say any of these values is a fruit name. And just like I showed before, we'd say this accepts a fruit name. And if I try to pass in monkey is not a fruit name. It is a string, but it's not a fruit name. And so I can narrow the universe of strings to just these 3 strings. And then we have type enums for like-ish things. We've already seen this, the canonical one being the file, file, folder, pipe, etc. But also you have things that are similar like array, uint8 array, and buffer. They all have similar methods on them. They can be used in similar ways. They all represent a byte of data. In fact, I probably wouldn't put string in here because it doesn't have the same methods. But you want to do a type enum where basically all the things are really, really similar, or the way that there's a narrow set of common features that you're going to use them the same way. So we could do the same thing. Here's a different definition of person-like, not the same as our previous definitions of person-like. Maybe I should have called this one human-like. But we could say a person or a human have some common set of features that we want to be able to use in some way. Call that person-like. So that's a type enum. And of course, you can actually mix them together too. One thing I want to caution is against using type enums where the types are not similar, where they are functionally similar, but not semantically similar. So a string, a number, and a big int can all be used to represent a number. But a string is not a number, and a big int is not a number, and a number is not a big int, and a string is not a big int. So they can all be used, they can be used to represent a big number, but they do not have a common set of functionality. You cannot use them interchangeably in any meaningful way. So in this case, what I'd recommend instead is that you have a function. If you needed to deal with some strings that are numbers, you'd have a function that's parse big int that takes a string. You'd have another function that's toBigInt that takes a number. Actually, I think there might be some native JavaScript built in for that already. And then you have a function that just takes a big int, and that's the only type it takes. Because otherwise, it just makes for messier code. You start to have more conditions and more ways that you have to do things. So you can do this, but it's one of those things I recommend that you stay away from. Now, an exception to that is when you're typing legacy code, if you've got some old code and you want to bring it up to snuff, but you don't want to change its API. This is where you'd use dissimilar type enums, like object and function. They have nothing in common, except that in my old school getImages callback function, if I don't supply any options and I just supply a callback, then I want to use, I'll end up reassigning the options to the callback, and if the callback's not defined, then blah, blah, blah. So it is useful for the legacy code scenario to use it that way. Now, the implied enums is the if it fits, it ships. So a lot of the stuff that I've shown you about defining likeness and templates, in a lot of cases, those aren't necessarily necessary because it's because of duck typing. Everything that can fit a shape. So if I have an object that is larger, so let's say that I define person as just ID and name, and that's it. If I want to pass in an object that has ID and name and age, it fits, it ships, because it has the minimum requirement. Now, there could be differences in that. So for example, it might be that I need ID and age and neither may be null. And I have an object that has ID and age, but it came from some function where it was returned that the age could be null. That would be a type incompatibility because the nullishness needs to be the same as well. But if the types and the nullishness of properties of what you need to receive or pass through have a minimal match, then everything is an implied enum to that, or I don't know if I'm saying that correctly, but it's because of duck typing, the fact that it matches an enum or an interface of all of those types that have those properties is understood. So I could also, you can also, let's say you had a turtle and you had a person. It's most likely that if you have a function that just needs something that has ID and name, whether you pass in a turtle or a person, it'll still work. and this goes into the difference between type aliases and new types that I'm just about to get into because of the whole duck typing system that JavaScript is based on. So a type alias is when we talked about this earlier with the name and great names and stuff like that. So if I want for documentation purposes to say, hey, this is not just a number, it's dollars. That's really important information. For documentation purposes, I can type def number as dollars, and that means that wherever I do a type of dollars, it will accept any number. This is fortunate and unfortunate. It's fortunate because we have the intent specified, and you can further do things like, dollars are separated with every 3 units or 3 decimal places. You can have a separator, and that helps clarify to the reader. But this is purely for improving documentation. This does not help you. It does not actually capture the type because of the implicit enum. Dollar is dollar or number by default, when there's no way to make that not work. What we would like sometimes is what's called a new type. And we have this in Go and Rust and most typed languages. And that's where you actually can say, hey, this is dollars, and it's a different type than, say, cents. And so cents here, and we could denote this easier in documentation by, if you see 3 zeros at the end, you know it's dollars. If you see 2 zeros at the end, you know it's cents, or you see your decimal place is delimited this way. But you would not want it to be possible to be able to take a quantity of things. So say your savings is in dollars and the price of something is in cents. You don't want to be able to divide your savings by the price to get the quantity, because that would be off by a factor of 100. But unfortunately, the way that new types work, you just can't do that. You only have type aliases, you don't have new types. And so something polymorphism. Basically, these are mix-ins. So we are. Oh, good night, sweetie. I love you, little girl. So if we were to type def a with friends type, and it has a property array of person, like we've already seen before, you can mix these in, and that's how you get your mix and match. That's how you share properties rather than there are ways to do inheritance, but again, I don't advocate those. If you want that, then just go to TypeScript, right? So if you want to be able to mix and match properties, this is the way to do it. Okay. We talked about type utils already. Oh, another one that's kind of useful is read-only. So you can say allow the properties to be read but not to be written to. And the thing that I kind of started to say before, but I want to say now, one thing about the type utils, because I'll just open up the page so we can take a look at them, I don't have that page. I don't have the link referenced here. But there's partial, there's require, there's non-nullable, there's pick, there's omit. But in the spirit of a little copying is better than a little dependency, a little copying is better than a little mental load. It's oftentimes a lot easier. I mean, I think the partial and the read-only are really useful, generally speaking. But if you're trying to do, you want to partial this, and you want to AND it with a required that, and you want to AND it with a pick this, and you want to AND it with an omit that, that's a lot of mental burden to be able to figure out and just kind of look at it and say, okay, what is this type? What actually is this thing? It's a lot easier if you just say, okay, well, I've got 2 types that are kind of similar, but they're different. So I'm just going to make a bank E type, bank member type, and a person type. And they're going to share a lot of the same properties, but I'm just going to make them different because I don't want to have to do all these mix-ins and use these utility types and then have the mental overload of looking at it and trying to figure out what it meant. Yeah, just because you can doesn't mean you should. Flat is better than nested. Avoid hasty abstractions. People aren't great at recursion. Everyone, ever. These are all just things to keep in mind before you get crazy with the types. Okay, so now we'll come back up for error. Quack, 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 quack. This was just because I was going to be flipping through these quickly and I wanted time to see it. So now we are at the time for Q&A. So hopefully we've talked about the philosophy behind why JS with types. It's not for everybody. The tooling that you need in order to get it to work for you so that you don't have a headache, and then the different ways that you can express types in JavaScript, and kind of the little a few more examples of how to use it. So I will open the floor now for more questions. Mavandi, Jojobite, Ragu, Kano. Let me see if I can go back to one of those examples. So you're asking about, because people on the stream can't hear you, I'll just repeat this. So you're asking about the nullable types. Oh, heaven help me. Hold on. Maybe I can... yeah, so you can have something be a non-nullable type and not define it immediately. In fact, this is one of the very first examples. If I can go back here, where was it? Okay, let's go back to this very first example. Oh, whoops. It was somewhere. There it is. So this right here, you can say var message, and you can have this typed as a string, and you don't have to assign it right now. You just have to assign it before it's used. Does that answer your question? All right. I'm going to go back to my QA slide there. So I'll wait around for another minute if anybody's got questions. And if you found this to be useful, probably not super entertaining, kind of dry, but if you found it to be entertaining, or if you just helped you fall asleep tonight to just listen to something, consider like, sub, and follow if you want to. YouTube or Twitch, CoolAge86. You can also join in the Discord. There's been a link that's been popping up in the chat every so often there for that. And if there aren't any more questions, which I would love it if there were, then we'll just have a virtual clap here. And then I'll tell you all good night. But I'll wait around for one more minute. Yay! Thanks for the emoji claps. Okay. Well, I do want to know, did you find this useful? Do you feel like this is something that you now have tools that you can use? Because that's my greatest hope here, is that people, especially Go people like you, Mavandi, can be able to use types in JavaScript and gain the benefit of the tooling and feel better about it. Is there a way to tell your linter that everything needs a type, and if it doesn't have a type, you get an error? Well, yes, but it's still that you are putting the comments on there. Yeah, it is. If you're using TSC, then it is required. That's the thing. That's what TSC does. TSC is checking while you're writing code, you're getting squigglies to say, hey, this doesn't have a type. Hey, this type doesn't match. So yes, you are getting that as you're writing your code, you're getting the live feedback. Yeah, there's two options. Because you have an existing code base, then you want to allow any. Because if you have an existing code base and it's not typed, you don't want to have to type the whole thing before you can get any benefit. So there is a switch in the JS config where you can say, you can say, I want to allow untyped types to be any's by default. It's basically, do you want it to be any by default or you want it to be an error by default? And the JS gives you a config that is error by default with the assumption you're starting a new project. And if you don't like that, then you can go in the config and you can see where it says allow any, and you can change it from true to false. Except for explicit any's. And Jojo Byte, you are now unsuppressed from talking. Sorry, you were server muted. And then I'll answer your question, Raghu, in just a second. Okay, saw you unmute. I don't hear anything. Okay, so I think there's something maybe wrong with your mic. I'm going to turn over Raghu here. So how much JavaScript is required for Node.js? It doesn't matter. So Node.js is JavaScript. You are not learning any more or less JavaScript, whether you pursue Node or browser. You're learning a different set of libraries. And in many cases, the libraries are actually the same, but there is not a different amount of JavaScript that is necessary to do Node.js or the browser. JavaScript is a programming language, and that language can run on multiple platforms. And anywhere that JavaScript, the language, can be run, you can use it. Some libraries are platform specific. So for example, you wouldn't run a web server in a browser. There actually is a library that is written for the browser that is a web server. There are people that have done these weird hacks, but generally speaking, you're not going to use a web server library in the browser because you can't serve web pages from the browser except for these weird kind of fun hack day projects that people have created where they run a web server in their browser through WebRTC or something like that. There are certain things that are available in the default Node library that are not available in the default browser library, and vice versa. So you'll find that you need what is called a polyfill, what originally was called a prototype, but has now been renamed to polyfill. You can get a polyfill that will add that library or the properties of those objects onto the libraries that are available in that environment. But you do not need to know any level of JavaScript to start with Node.js any more than you need JavaScript to start with JavaScript. You could ask the same question: how much JavaScript is required for browser.js? Whatever. So hopefully that's kind of clarifying in terms of understanding, what there's programming languages, programming libraries. Yay, it's working. Yep. Awesome. Well, remember jswithtypes.com and JS what? I think the best experience is the best teacher. And so if you just JS what init a project and start using it, are you using Vim or VS Code primarily? Yeah, so with VS Code, there's a chance that VS Code popped up at some point and said, hey, do you want to enable TypeScript checking? And you may have clicked no. So you may have to Google, how do I unknow that? But other than that, the TypeScript checker is built into VS Code. So if it is installed, it should be used. Or it's... Yeah. But Yeah, I would say just do run npm install location global TypeScript and then JS what init, and then just open up your project in VS Code, and there's a really good chance that it'll just start working. Cool. You're welcome, Raghu. Raghu just said thanks. Okay. I'm going to be on for 1 more minute. If anybody wants to ask final questions. And I do appreciate the questions, so keep them coming. You are welcome. All right. Well, with that, thanks everybody for joining in. I hope that at least somebody got my little joke here on my end slide. And feel free to drop questions down in the comments. I want to improve the jswithtypes.com slides and whatever will become of the website, which I think I'm just going to try to take the slides and turn it into more of a scrollable format and fix a couple of those mistakes. And I really want to help people with this problem. I think it's a really important problem to solve. We don't need a superset of JavaScript. JavaScript has already kind of become too big. We need a subset of JavaScript, and I think JavaScript with types is a way to start pointing us in that direction. And hopefully JS what is a good tool to initialize a project so you can use that TypeScript tooling as a way to get started with that. So yeah, thanks again for tuning in. Everybody have an excellent night. Like, sub, follow, thumbs up, etc. if you got them. And I will catch you later. Feel free to join the Discord, yada, yada, yada. Adios.